Football gets bumps off of the edge of your table. It hits the ground 0.3 meters away from the table. And we want to know, well, then how high is the table? That's our question mark. So now we got to plug all of our numbers in to where they belong from this particular problem. So we know that the paper football is going to be 0.3 meters away from the table. That's x displacement or distance. The problem tells us that the paper football was moving 0.6 meters per second before it flew off the table. And it says, hey, how high is the table? Basically, what's the distance that this football fell in the y direction? And this is horizontal projectile motion. It doesn't have any initial upward or downward speed. So the initial speed in the y direction is 0. And every projectile always has an acceleration of negative 9.8 meters per second squared. So what we really want is something in the y direction, but we don't have enough information to solve. We only have two things. So we need time. Time is what x and y have in common. So we're going to solve for time in the x direction. That'll give us time in the y direction. And then we can solve the rest of the problem. So in the x direction, we only have one equation in the x direction because it's constant velocity motion going left and right. And that's d equals v times t. Do a little algebra, and you get t equals d divided by v. I can plug in my numbers, and I get 0.3 meters divided by 0.6 meters per second. When I plug that in, I get half a second for the time. I just plug that in my y. Since it's the same in the x and y, I know time is 0.5 seconds in the y direction. Now I pick the equation that will get me the distance. I want the one that does not have vf in it, since I don't have it, don't care about it. So that would be the equation d equals v naught t plus 1/2 a t squared. Since initial velocity is 0, we can cancel that whole term, make your life easier. And we get d equals 1/2 a t squared is my equation. No algebra needs to be done. It's already set up for the distance, which is what we want. We just have to plug in our numbers. 1/2 times negative 9.8 meters per second squared times 0.5 seconds squared. And I get a distance of negative 1.2 meters. That's how far the paper football fell, and that's the answer.